Welcome to the Patterns Physics video on resources for data discussions. All right, here we have one of our favorite posters, Swirl. Speak, write, interact, read, and listen. We know the research says students learn best when they're swirling, and that is, powerful for building their STEM identity, language competency, and just, feeling like they get it. So we want them swirling, and one of the best places we do this is in data discussions. So I'm going to go to the website and show you some resources that are in zero files because they apply to every unit. And then I'm going to scroll down to the zero poster. And so a lot of these can be printed and hung up right on the wall. And you will notice that many of what I'm about to show are embedded in the activity slides for the tasks in each of the units. So they're right there. So you might not need to go to zero poster, but just want to show you that they are all there. And if you want to print some out to put on your walls. So I have selected a few, and I want to start big picture right from day one of the curriculum, not necessarily day one of school, that here we have the making better predictions using inquiry. And so data discussions play a key role in this green box, making sense of the pattern through consensus. Another really big picture idea is one of the biggest ideas in physics. And that's we can study something in the world, we call it a system, collect data, explore the patterns. So often in physics, that takes the form of a mathematical model to both better understand the system and predict/influence its future behavior. And so we want students to realize they're doing the real stuff here. They are in the role of scientist. Another really big graphic that captures a lot of the good stuff is this triangle, and we call it walking the triangle, or the triangle of understanding. When you really understand something, you have a feel for the experience, what is really going on in the world. And then so often we want a diagrammatic display, and with data, that oftentimes takes the form of a graph. And then so often we leverage that graph and our understanding of what's going on in the world to make sense of the mathematical model that we created. Sometimes they can get that mathematical model from Desmos more as a black box. They just curve fit it. They don't know what the mathematical model, why. And so data discussions are to answer that question. Why is that mathematical model effective and applicable? All right. So here I'm going to show 3 slides that are in the zero poster file, but they appear every time we have a data discussion in the class. And this is this overview one. Again, this is an excerpt from the Inquiry Cube. Scientists present their explanations and critique the explanations proposed by other scientists. All right, and so here, this is an easy one to skip, but I just want to say it can be useful to take just 30 to 60 seconds to orient everyone, right? We do a lot of data discussions, but it's still very valuable to just let people know the structure. That first one, quality control of the data in the graph. We want to make sure we're not confusing students with erroneous data or mixed up data. Then orienting to the data. Students lots of times want to just jump in to similarities and differences, or someone who thinks they have it all figured out just wants to say some answer, but that's not what data discussions are about. It really is about constructing their learning. So we want them priming their brain with all of the different features here that they're interconnecting for the understanding. And then of course, yes, finding similarities and differences, low floor, high ceiling. A student who is even absent for the data collection, they can come in, and we have this graph here on the screen right now. They can notice they all go down and over. Some are close to the origin, some are farther away. They start off steep and then they become shallow. So again, low floor, high ceiling, so much more to go beyond that. Now that is in service to really these next couple. That is so that we can start to explore the pattern and walk the triangle, which really in this sense is making sense of the pattern, is the walking of the triangle. And that then, guided by our essential question, allows us to predict the future behavior of that system we're studying. I do want to just show this one. If you are kind of going over it, sometimes it's nice to have it a little bit larger. And then this is probably the single best slide to have up during a data discussion. And we have just found that these questions, these have been iterated, tens to hundreds of teachers. And these 5 questions get students talking more. So often get similarities for each point on the triangle. So often students will notice something about a graph. Oh, one line is steeper than the other. All right, so they should be able to find something in the mathematical model. And oh yeah, one has a bigger number than the other. And oh, something in the real, oh, one of those was going faster than the other. All right, so anytime they find a similarity, you should be able to find 2 more as you walk to a different part of the triangle with that feature that was mentioned. Same thing for differences. Oh, I actually did a difference for the similarity now that I'm thinking about it. Similarity was they both curve upwards, which then in the mathematical representation, oh, they both have an exponent 2 in them, or diameter times diameter. And then of course that they notice that in the real world, sometimes when you expand a container by 1 centimeter from 4 to 5, that has a different impact than expanding it from 10 to 11, which really allows more marbles to fit. All right, then number 3 is using straightforward words of understanding before technical terminology. And that's where we want that richness. And we want, as Oki Lee says, to be technical terms are a product of science. When we're really trying to be accurate and descriptive, then we'll want to introduce the technical terminology, not sometimes just feeling like they're trying to force it and maybe even using it in an unconventional way that's causing confusion. So we want them really understanding, and then, of course, building proficiency with the technical terminology. 4, very common, we do it with several of the warm-up questions and every data discussion, launch a discussion using the same input. Hey, when your container was 6 centimeters in diameter, how many marbles fit for you? 12? Oh, for me, I had 24 fit. Oh, wow. Okay. There's something different about your experimental setup than mine. And then, of course, you can do the same thing with an output value. Hey, when I had 15 marbles, my container was 5 centimeters. Oh, 15 for mine was only 3 centimeters. Okay, so these are just things that get students talking, and then those connections start happening. All right, and then one more slide just to show it is useful. It's a poster for us hanging up on the wall. It's just the constant C value, how it shows up in each of the patterns that spiral throughout the whole year. All right, so now I want to look at Unit 1, thinking that a lot of people will be watching this video while they're going through Unit 1, but I will show later Unit 3 to show you that some other resources come up as you go through the course. So here we are in the packing tomatoes experiment, and the activity, lab report, Desmos, data discussion in the packet with card sort. So I'm going to take a peek there. Here we are in the packet. I'll just quick scroll down. That's the first data discussion. And I'm going to go to the second one, the marble. And I'm not going to go through every box, but graphic organizers are powerful, right? There's just a box for each little thing that we want to make sure students talk about, defining description, small ball bearing or cherry tomato, big ball bearing or heirloom tomato. And then, determine the data point from your graph and share it. Hey, when I had a 10 centimeter wide, 80 ball bearings fit in mine. And so they're just again, that's that orient to the data. And then of course, here's the similarities and differences, and they're analyzing that. Now, we have gotten the feedback that sometimes, especially with quadratic and inverse, students spend a lot of time hand drawing it. And even after they hand draw it, it's not precise enough for them to make predictions. So we want to give you a couple solutions and options. One, you could, for a class, especially with consistent data where you know that the ball bearings will result in a very repeated mathematical model, you could print out the data discussion with the graphs in it. Or if each period is a little bit different and you want to customize it to that period, I wanted to show you the slide So I'm just going to go down and we got all these slides for it. And then I'll just show that. But here, again, lots of slides to guide you through the data discussion. Here's those common ones I just said. And I want to go to the pre-made graphs. There's always pre-made graphs. And if you click on it, you can get to the very Desmos that generated the graph. And so you can put in the equations that your students got. And then we suggest just going ahead and printing them and, print like 9 per sheet. They can cut those out and paste it in to the packet if you already have that printed and want it customizable. Again, these offer the benefit that they're precise enough. You can really double from 5 to 10 and draw up and over, annotating that graph so that really every student is getting the information that they need from their graph, because it is drawn well enough to do that. To keep going, I want to show the card sort. So here, these 9 cards would all get cut up and scrambled, and then students have to arrange them, group them together. And this is a great one to show because so often students think the larger the marble, the larger the constant C value should be. But of course, it's the exact opposite, because this is not the size, it is actually the packability, or roughly speaking, how many marbles fit per square centimeter. It's not exactly how many fit per square centimeter because there's all those air gaps. But in any case, students don't even have to realize that, but they will realize that large marbles have a small number. And so that frames the question. What does the small marble have more of than the large marble? It's not size, it's not mass. Oh yeah, we're talking about packing tomatoes. Yeah, it's more packable. Excellent. So that card sort is a fan favorite. Students and teachers developed it during distance learning, and everyone wanted that for in-person learning. It's great. There's a lot of synthesis that happens in students organizing these cards. All right, so zooming out. Oh, I meant to actually show this one first. This is a great slide to show. The most important things need to be said multiple times in multiple ways. Okay, so we know this. We want students to have a chance. That's why we're oftentimes trying to have the smallest group that we can. And I'm about to show resources for small group data discussions. We just want they need repetition. They need practice. It's going to really help with language development and using technical terminology. All right, so we want them to be the most important thing. So, oh, that was a great explanation of why the pattern makes sense. Could you repeat that? Oh, could someone say it slightly different way? All right, excellent. We just want lots of repetition. And if this next one's a little cute, but if you like it, it seems students have liked it. So we have this little taggy toy, babies love these little tags. And it sort of organically happened and so we actually then went and bought a stuffed animal with this. And we just, on the most important things, there's like 10 tags on this thing. So we have students repeat it 10 times, and they can repeat what was said before them. They can say it, they're encouraged to say it slightly different or how they understood it. And so that just gives them reps, and it's kind of fun. And one quick short story is that one time I wanted to stop kind of halfway through because I thought we had it and we wanted to move on. And, students are like, no, you got to finish it. And so, they can toss it around until all the tags are used up. So just a fun thing if you think that might encourage your students to say the most important things multiple times. All right, so I did say that I would show unit 3. So I just want to go here. We're looking at the investigation to determine the mathematical model for elastic energy. And if we go down to the resources, I just want to show this one, the group facilitation guide for data discussions. So I already have it open, so I'm just going to open it. Here we have it, group facilitator guide. So it's partially filled out. It has some guiding questions for students to ask. And the idea here is that you would pull up one student from each group and you do a mini data discussion and, talk about leadership and how they're really meant to be the facilitators getting students to talk. And you might go through that with them. Now, students might need more support than that. I hope that's a good one. But if they do need more supports, and this is something you can use in unit 1, I just waited till now to show it, is these cards for leading data discussions. Again, that's in 0 files because it applies to all of them. And so we can just see that there's 3 things that they can check on for quality control: orienting to the data. They have 5 points. Similarities and differences, it has them do a whip around. We want as many students talking as possible. So this has every student in that small group of 4 comes up with a similarity that they see. And then student A goes B, C, D. And so just a structure, not amazing, but just is clear and concise, and students can read these cards. And then of course, here are those 5 ones that just get students talking. It's pretty good. Hopefully that works for you as well. And then the making sense. So here are some cards that allow small group data discussions that have more students talking. So that is most of the good stuff of the resources we have for having as many students productively talking during data discussions as possible. I hope that helps.